So let's go ahead and do a density problem. And as I said, all we're going to do is we're going to isolate an object and we're going to take its mass, probably weigh it on a scale, and we're somehow going to come up with its volume, and we're going to do a division, and we're going to make the units of mass per volume. Okay, so here we go. This actually, the object we're weighing has nice straight dimensions. It's a block, okay, has a length, width, and height, and usually you would tell me volume is equal to length times width times height. So actually what we're going to do here in a minute is multiply these three values together. Now one thing is throughout this course, when you work homework problems and when you work problems on a test, you always have to show all work. And that means that you have to show what you're multiplying together. Okay, and we're going to have to round correctly. So we're going to do that, come up with the volume. Here's the mass, and then all we're going to do is a division. So density is equal to mass, we got at the bottom there, divided by volume that we're going to get coming up with the length times width times height. Sometimes chemistry problems or physical science problems just don't make them harder than they are. It's one of my little bits of advice for the day. So volume is equal to length times width times height of this block. And again, don't forget to show all of your work. And the more descriptive you can be about how you're solving a problem, the better off you're going to be. You're going to be better off because you understand where you are in case you want to go back and modify something. You're better off too for the person who's reading it and they're like, oh, that's what they did. And every once in a while, if you don't quite get an entire problem right, if you've shown the teacher kind of how you've laid it out, they can kind of go back and make that work for you. So here we go. Length times width times height. Show all your work. And we do a lot of, we multiply the numbers together, and then we multiply the units together. So here's the numbers. Okay, we multiply them together, and we get rounded to the right number of significant figures, this number, and then we take the units, centimeters times centimeters times centimeters is equal to centimeters raised to the third power. Especially early on in working these problems, until you kind of get the hang of rounding, a lot of times I will encourage students to write the unrounded number. So I'm going to go ahead and write the unrounded number up here as, let's see, I wrote it down. Yep. 1.76358, and units would be centimeters cubed. And can you see why I wrote the 1.8? Because I have three significant figures here, three significant figures here, two significant figures here, so I have to only go with two. So I keep 2 going from the left to the right, so I'm going to keep these digits and I'm going to truncate it right here. And since this is a 6, I need to round the 7 up to an 8. So 1.8 is what I would report there. And I think somewhere in my notes I said you need to start rounding correctly with regard to the even intermediate answers. And this is an intermediate answer because our next thing is to take the mass divided by this volume. So here we go, the mass divided by volume. So if I take, now this is actually a little bit controversial. Like, how could you be controversial calculating the grams divided by volume here? But if I go ahead and take the mass that was given on the first slide and divide it by the volume that I just came up with, I get, and I'll go ahead and write, sometimes I'll write calculator value, and oh, my thing's going dim here, calculator value, and I would write 7.7, looks like 444 repeating, okay? Of course, units would be what? Grams per centimeter cubed, and that is my calculator value. And let's see, how do I need to round it? Since I'm dividing, I round according to sig figs. I have 4 sig figs up there, and I have 2 sig figs here, so I am only allowed to round according to 2 sig figs. I count from left to right the digits, and I'm going to truncate it here. Since this is a 4, I'm going to leave the 7 the same, and my answer is going to be 7.7 grams per centimeter cubed. voila, okay? So if I write this as calculator, then I write the real answer down here, ANS for answer, and I circle it. Sorry, I know that's a little bit messy. So now I mentioned this is a little bit controversial now. The deal is what if I were to take this unrounded value that I had written up here, that unrounded value again is that 7.7, sorry, that's not the unrounded value. The unrounded value up here for the volume is that 1.76358 centimeters cubed. If I were to take that instead of 1.8, honestly, what I would get then is, what I would get if I take, instead of this number down here, I go with 1.76358 centimeters cubed. If I do that division, then I get, what my calculator displays is 7.9043, looks like 8, and units of course would still be grams per centimeter cubed. Okay, now this is different then. I know it's different, and that's my problem, not yours. If you use an unrounded value like this, actually there's a chance you can get a little more accuracy, but if you use an unrounded value down here instead of my correctly rounded to 2 sig figs, 1.8, then I lose track of how I need to round it. So I kind of encourage students to round as you go, but if you don't round as you go, you actually get a different number. You're like, oh my gosh, are you serious? So again, I need to round to 2 significant figures, so I go from left to right. I got this digit, I'm going to truncate it. So actually, my answer using the unrounded value is 7.9 grams per cubic centimeter. Now, could you do a 7.7 grams per cubic centimeter? Yes. Okay, using the rounded value here. Could you use the unrounded value and round correctly and get this? Yes. Okay, so I hope that makes sense. I kind of catch you on the other side if you've used an unrounded value, or yeah, use the unrounded value in your calculation. So this is just kind of an important little tip. Not only do we need to round correctly, but when we're using measured quantities and we use an assortment of measured quantities, we need to always have the number and the units with it. And then as we multiply or divide, then those units go with the calculated value.